Hello everyone, welcome back. Today we will be entering chapter 5, which is on work, energy and power. So I guess there'll be 3 subtopics explaining these 3. I forgot sudah berapa banyak subtopic. But let's look onto the first subtopic, which is on work. Right, so in this subtopic you should be able to define what is work done by a constant force. So basically this is the formula for work done. And then you also have to be able to apply this work done punya formula and then apply it from and also finding the work done from a force displacement graph. Okay, so what is work done by a constant force? So we know mathematically it's this one, but if you were to write it in sentence, it is the product of the force parallel to the displacement times dengan the displacement of a body. Okay, so remember the force is the force yang parallel gitu kak, parallel punya symbol, tapi dia parallel lah. Okay, and then the angle theta here is the angle between the force and the displacement lah. Okay, so work done is a scalar quantity, so it has the unit joule. Okay, you should write joule as the unit. It is the SI unit. So 1 joule is a work done by a force of 1 Newton, which results in a displacement of 1 meter in the direction of the force. Okay, sometimes they would ask you what does 1 joule means, so you have to be able to explain that. So you kind of have to memorize this lah. Okay, so 1 joule is equal to 1 Newton meter, also equal to 1 kilogram meter square per second square. Okay, alright, now let's see. Alright, we'll go into examples later. These are the application of work's equation. So if we were to have a work done by a horizontal force, they would be a work done. Work done dia tidak akan jadi zero. So there's work done. Lepas tu, if the work done is by a vertical force, sini dia tulis vertical force, then theta is equal to 90 degree. Cos 90 is equal to 0. Okay, so that's why if the force is perpendicular to the displacement, then there is no work done. Okay, there is no work being done. And then the third case is when there's 2 horizontal forces acting on an object, then the work done is just the addition of both work done by force 1 and by force 2. As long as it is parallel to the displacement here, then there is a presence of work done lah. Okay, and then the fourth case is work done by a force and a frictional force. Again, this one you have to find the net force in order to find the work done by the work done on the whole system here. So for this one, yes, there is still work done because the angle is not equal to 90 degree. Okay, alright, you still have to consider the direction for the force and the frictional force lah. Okay, although this work done ni is just a scalar quantity, you still have to consider the other components punya direction lah, yang vector quantity. Okay, so this one is work done from a force displacement graph. So basically the shaded area under the graph of force against displacement is known as the work done lah. Okay, so this is the integration, then you'll get work equal to force times dengan delta S, which is the change in displacement lah. Okay, there's movement lah, that's why dia ada minus di situ. Okay, so it's the work done on an object is 0 either when the force is equal to 0, the displacement equal to 0, or the theta, the angle between force and displacement, is equal to 90 degree. Okay, so these 3 cases would equate to a work done to be equal to 0. Okay, great. Now what is this? So this one, spacecraft traveling, work done is equal to 0. sebab constant velocity, acceleration is equal to 0. And then work done equal to 0, force exerted on a building. How can you push a building, right? So if the building is stuck here, you won't be doing any work. It's useless. So that's why the work done is equal to 0. And then centripetal force acting on the car. So this one, the angle between the force as well as the velocity, which is the displacement of the car, is 90 degree. That's why the work done here is equal to 0. Okay, right. So if you obtain a positive and negative value, which you will be obtaining, actually you will get positive and negative value. But we mentioned that work is a scalar quantity. So what does the positive and negative value means? So basically, work that is greater than 0, which is positive, means that the work is done on the system. Okay, so this external force is causing work done to be on the system. So in this case, the energy is being transferred into the system lah. Okay, and then if the work done you've obtained is a negative value, then it means that the work is done by the system. Okay, this done by the system, where the energy is transferred from the system. Okay, so that is the meaning of positive and negative values of work. I think that's the end of the theory part for the first subtopic. We will go into the examples in the next videos.